happen here. So over on 29, we're supposed to solve the equation. Now, it didn't give us a range to solve the equation in, which means they want all the solutions that could ever happen, not just one trip around the unit circle. So that's going to affect how we look at our answers in a minute, or we're just going to have to tweak our answers at the end, basically, is what's going to happen. So here we go. 3 cosecant squared x minus 4 is equal to 0. My goal is to get cosecant x by itself on one side, just like I had in problem 19 that we just worked, okay? So if I want to get it by itself, it's kind of like solving for x that you did. You know, we're trying to get the cosecant x by itself. So let's take care of moving stuff. Remember when we solve things, we're solving for cosecant x. We do PEMDAS backwards in case you forget the order to solve. So we would add or subtract anything first. So when we add the 4 to the other side, or we'll add 4 to both sides, right? So that's going to give me 3 cosecant squared x equal 4. And then I could, I don't have anything else I can add or subtract. Now look, let me look for something to multiply or divide. Couldn't I divide both sides by 3? Okay, so we'll do that next. Okay, so that leaves me with cosecant squared x is equal to 4 over 3. Now I don't have cosecant x by itself. I have cosecant x squared. So what can I do to make it just cosecant x? Square root both sides, okay? So that's what we're going to do. Now, I just square rooted, right? I did it. No, they didn't give it to me already square rooted. Since I square rooted it, what I have to remember is that when I square root, I have a positive root and I have a negative root. Anytime I'm solving and I square root, I have to write that plus or minus on there. If they've already done it and there's a square root and there's no plus or minus on it, it means I only have to consider the positive root. But when I do the square rooting, I have to remember there are 2 different answers, a positive one and a negative one. So here's what I got. I got cosecant x is equal to plus or minus the square root of 4 over 3. Well, the square root of 4 is on top 2, right? And then the square root of 3 on the bottom. Okay, that's probably not the best way for me to look at that. Well, actually, it might not be too bad to leave it this way. They want me to find the angle that has this cosecant, don't they? Doesn't they? It's early, right? Okay, so I could, you know, if I were going to give this as an answer, I could go ahead and rationalize it, but here I'm not going to because I really kind of like the way those numbers are. Don't those numbers look like what I see when I look at my triangles, right? A square root of 3 and a 2. If I were to say that's 2 square roots of 3 over 3, that kind of messes it up when I'm trying to figure it out, doesn't it? So we're not going to go do that here because that's not really what we're going to give as our answer. They want the angle. Remember, we're trying to find the angles that have this, you know, this number as their cosecant. Okay, so again, we're looking at a 30, 60, 90, aren't we? Because we see that square root of 3 and a 2. Remember, this was labeled in a different color over here. This would be x, this would be x square root of 3, and this would be 2x. So cosecant is the reciprocal of sine, right? So if sine is opposite over hypotenuse, this is hypotenuse over opposite. Which angle has an opposite side of square root of 3? What angle am I talking about here? 60, yeah. We've had 30 a lot, but now we get 60. We're talking about a 60 degrees reference angle, and 60 is the same thing as 180 divided by 3, right? So this would be pi divided by 3. That'd be the quick way to figure it out. So this is pi thirds in radians, because they really always want us to give our answers in radians unless they say it's okay to do degrees. So we're going to do radians here. Okay, so we're talking about a 60-degree reference angle. The other thing, if you remember what we were doing in the problems where we didn't actually have to do much algebra on them, is I would always draw this, wouldn't I? What quadrants do I want answers in here? I want the positive ones and the negative ones. Isn't it all 4? Right? If it were just negative, I would have 2 quadrants. If it were just positive, I would have 2 quadrants. But since I put the plus or minus on it, that means I'm going to want the reference angle in every quadrant. And if you think about it, remember that when I graph these things, you know, they're periodic. They repeat. You know, there's just an infinite amount of angles that have this because we can just either keep going around the unit circle, if we're looking at the unit circle. Or if we graphed it out on an XY axis, it's just going to be a repeating graph over and over again. So we got to find a way to say that. That's the kind of challenge here, okay? So we're talking about pi thirds. Let me see. Let's think about cosecant is the reciprocal of sine, so we're going to use sine as our guiding thing here. We're going to kind of look for some patterns here on this All Students Take Calculus. Sine would be positive here and here, right? So let's just work with the positive answers first, and then we'll go look at the negative answers. This gets a little complicated here describing it when they want us to give all the answers that ever are, okay? Here we go. Let's see. I could, okay, so one of my answers is pi over 6, right? But if I go another trip around the unit circle, I'll end up there again, whether I go clockwise or counterclockwise. So how I can describe that is to say plus 2 pi n. That means if I go up 2 pi would be go another trip around the unit circle, okay? So go full circle when you see plus 2 pi. The n, we'll say that's an element of integers, okay? So I could put a positive 1 in there and go 1 trip around the unit circle if I make my n 1. If I make my n 2, that's 2 trips around the unit circle counterclockwise. But what if I wanted to go backwards? I could put a negative 1 in and go the opposite direction and still end up in the same place, okay? So I could describe all the answers that would fall in quadrant 1 this way. This is just the quadrant 1 answers if I just go a full circle, either clockwise or counterclockwise. Let's look at quadrant 2. Quadrant 2, I'll make it green. This would be pi, but I'm not quite there. I'm pi thirds short. So pi minus pi thirds. Kind of hard to know where to work here. Pi minus pi over 3. If I have 1 pi and I take away a third of a pi, wouldn't I have 2/3 pi left? Couldn't I think of that fraction that way? 2/3 pi would give me that answer there, but again, I could go a full circle clockwise or a full circle counterclockwise, and I would have another answer there. So how I can describe that is to say plus 2 pi n, and then we'll just for all of these assume that we're talking about an n being an integer. The reason I'm saying it's an integer, I don't want to go half the way, or I don't want to go part of a circle. I'm going to go a whole circle, right? So I don't want to say, I only want it to be whole numbers. So we were going whole trips around the unit circle, either this way or this way, okay? That's how you describe it. So there's another answer. All right, that's the positive ones. Now the negative ones, okay? The negative ones are down here in these two quadrants, aren't they? Okay, so that's going to be pi, let's see, for the one in the third quadrant, pi plus pi over 3. 3 over 3 pi plus 1 over 3 pi would be 4 over 3 pi, or 1 plus a third is 4/3, right? So that's going to be 4/3 pi, and what am I going to have to add on it? Because I can go a full circle either direction. Yeah, plus 2 pi n, okay, so not all of them are going to need this many. A lot of times there's, some of them there's an easier way to describe them, and we'll get to some of those in a minute. And then there's one more over here. This was 2 pi minus pi over 3. And if I got a common denominator, if I multiplied 2 by 3 over 3, wouldn't that be 6 pi over 3 minus pi over 3? That would be 5 pi over 3, right? So I would have 5 pi over 3 plus 2 pi n. Now, when you look at what we got here, okay, I did this intentionally, okay? There's a shorter way I can write this. There is a shorter way I can write this. Do you see that when I get done, let me draw all these in. Do you see that these 30-degree angles are making a line? Like, for instance, let me highlight in yellow. Because I had positive and negative solutions, because there was a 30-degree reference angle in every quadrant, do you see in the end that these kind of end up making a line? You see that? Okay, because that's why I'm drawing the yellow there. The book's not going to give you all these answers. Here's what the book's going to do. They're going to say, well, hey, I don't have to write all that out. That's an awful lot to write out. And, of course, we've already done it. But there is a quicker way to write this. I could just say it's this reference angle, and instead of going around 2 pi, if I just go around pi, that's going to put me on the other side of that line and give me the other angle. So here's how the book's going to write the answer. They're going to say that's just this angle, which is your pi over 6. And instead of saying plus 2 pi n, they're going to go, hey, wait, there's a way to write all these 4 things closer, and it's to write pi over 6 plus pi n, okay? Instead of writing 4, we're going to end up only with 2 things written out as our answer because we can do it that way. If you look at the drawing here, okay? Now, what about this other way? Let me pick a peach color. Don't this green and this red one here make a straight line this way, right? So if I start maybe with this one right here, this one was in quadrant 2, that was 2/3 pi. Let me write it up here in black. It's this one right here in green that I'm looking at. It's 2/3 pi, but if I go another pi degrees, if I go half a circle, I end up at the other one, right? So I could say that's 2/3 pi plus pi n, because I can go half a circle to get to another solution. It doesn't break them up all positive and all negative, but it does tell me where all the solutions are where n is an element of z. Hannah? You're right, so sorry.
I've been so thrown off.
So sorry. I wish, yeah, speak up when you get thrown off because there's a good chance. Okay, so what we've noticed is I've miscopied something here. I said that the angle over here, let me kind of pick a color that I can, in a light purple. My angle is supposed to be pi over 3. And so I actually wrote pi over 6 over here. I think I just kind of, those 3's and those 6's in my brain just get all thrown around. No, we did the right one on the other ones, right? It was just that one. So this should be pi over 3 here. So if you're watching the video and got confused, I took this pi over 3 and accidentally wrote it as a pi over 6 over here. Just kind of got going and the wrong one came out of my mouth and I wrote it down wrong. So we need to make that correction. Everything else should be right. I just goofed up right there when I copied this one over.